So I have a question for you.
Okay, yes, ma'am.
I can't get into my e-text for some reason. I don't know why, but I can't. I have the actual book like in front of me right now. Am I okay to use that, or do I have to use it online?
You can use whatever you want in class.
Okay.
You can use an old book, a new book, a used book, share a book, don't bring a book, print a book, whatever you want.
All right.
Okay.
Okay? Any other questions? Okay. Now, when you classify as prime or composite, you need to understand the difference between the two. I call the prime numbers the ugly numbers. What do you mean ugly? You don't want to work with them. Like 7, 11, 13. Those are numbers that when you think about it, nothing goes into 7 or 11. But what's the definition of prime factorization? The definition of prime numbers are numbers that are only divisible by themselves and 1. So I'm going to go to your handy dandy book, and you're going to look at your book on page 205, and you're going to write down those two definitions. And the reason I don't change those definitions is they're pretty short and sweet. Prime number is a number that only has two factors, itself and 1. What do you mean? Well, what about the number 2? What numbers do you multiply together to get 2? 1 times 2, or 2 times 1. How about 7? 1 times 7, 7 times 1. There's no other number that will go into 7 besides itself and 1. Now there's a little list of prime numbers right there. Write them down. 2. I don't know what I just said. 2, 3, 5, 7, 11. And I really want you to go to 13, but you can write down the other 2 if you want to. And the opposite of a prime number is the other numbers, which are composite. Composite numbers can be divisible by other numbers other than 1. So what about 4? Well, 4 is divisible by 2, or it's divisible by 4. So it's got 2 sets of numbers. How about 6? 6 is divisible by 6. 6 is divisible by 2. 6 is divisible by 3. So it has multiple numbers that will go into it. So there's 2 types of numbers. There is the prime numbers, which are yucky numbers that are only divisible by themselves and 1. And then you have the rest, which are called composite. Give you one more minute to write those down. So, example of prime numbers, 2, 3, 5, 7, 11, and 13. Ooh, I didn't know I could do that. And there's an example of, that's something new. There's examples of composite numbers. Now, what are we going to be working with? We're going to be working with prime numbers. Prime factorization. Because if you can break a number into its prime factors, you have broke that number down to this base, the base. Okay? You have got it broken down to its smallest numbers. Okay? And that's what prime factorization is. Now, what is factoring? Well, a lot of people don't even know what factoring is. So I'm going to tell you what factoring is. Factoring is breaking up a number or a term or term into its factors, its multiples or its factors. Prime example, 54. If I gave you the number 54 and I told you to factor it, most of you would say what? 6 times 9. Okay? Why would most of you say 6 times 9? Anybody want to take a guess at why you would say 6 times 9? That's when I want y'all to interact with me. Because y'all remember 6 times 9 from your what? Everybody learned them back in the 3rd and 4th grade. Multiplication tables. Nobody ever learned, 2 times 27 is 54. Nobody ever learned 2 times 27. Okay? But you learned 6 times 9. So whenever somebody asks you to factor a number, you revert back to your multiplication tables. If I asked you what is the factors of 49, you would say 7 times 7. You wouldn't say, 1 times 49. You would say 7 times 7. Now, unfortunately, that is the composite factor. If I wanted to break it up into, this is the composite factorization. And we're not really interested in the composite factorization. We are interested in the prime factorization. The prime factorization would be to break these two up into prime factors, which would be 2 times 3 and 3 times 3, which we would change that to 2 times 3 to the 3rd power. And that is what we call prime factorization. And prime factorization is our first thing that we're going to learn in 5.1. Okay? So we need to put out of our head, we need to forget up to a certain point, we need to forget our multiplication tables, not completely, but we need to forget as far as factors. But if you want to remember 6 times 9 in your head and then drop it down a level and say, okay, 6 is 2 times 3 and then 3 times 3. If you want to do that, you can. But you need to forget it as far as this word. You don't want to think, okay, I'm factoring this number. No. From here on out, in chapter 5, you're going to be factoring in prime factorization. Okay? And that's what they're going to be talking about. And I'm going to show you, we'll just do another number here. Let me just go to my next whiteboard. And that's my problem. I try to use the PowerPoints because they're organized, but then I get off of them and I go all over the place. So let's do 144. Now I'm going to show you how I do prime factorization because I do not use the factor tree. 2, 3, 5, 7, 11, and 13. I always put those numbers up there because those are the only numbers you can use. And if you write those up there every time, you won't be using 6 and 12 and all these other numbers. So I want you to start breaking that number up using those. You don't have to use all of them. Just using those 6 numbers. Well, what's the first one that you think? Well, it ends in 4. Now, let's go to a chart in your book. I'm going to take off from this for a second. Now, bear with me because I do this sometimes. And rules of divisibility, page, hold on, I'm I'm looking to see if they have it on page 206 or not. Okay. Let me go to the PowerPoint, see if they have it. There they are. There's the first rules on page. Let me see if it come up on it. No, the book is still working. So go ahead and draw a little bit of a chart. We're going to go all the way to 9 probably. How do you know a number is divisible by 2? It's an even number. If you look at a number, 1024, then you know it's divisible by 2 because it's an even number. How do you know it's even? Because the last number is even. Okay? 2, 4, 6, 8, 10. If it's 2, 4, 6, 8, or 0, it's divisible by 2. How do you know if a number is divisible by 3? Well, you can add them up, add the 3 numbers up, and it is a multiple of 3. So if I add those 3 numbers up, I get 15. 15 is divisible by 3. So it's divisible, the number is divisible by 3. Again, these are probably 2nd, 3rd, 4th grade things that you should have learned. But some people forget them, and I understand that. Is the number divisible by 4? Well, is the last 2 digits divisible by 4? Yes. And 924 is. If the number ends in 0 or 5, that's an easy one. Most of you remember that one. If a number is divisible by 0, if the number ends in 0 or 5, it is divisible by 5. Let me see if let me hit refresh again. Maybe it'll come up this time. The reason I'm trying to get the book up is it shows the whole chart and not just part of the chart. But there we go. There we go. Page 206, for those that have a book, you need to mark it. So I'm going to take a minute and y'all write that down. Yes, ma'am.
How do you get to the online book?
You hit e-text. You should have it on the left-hand side. E-text. And then just type in 206 right there at the box, and you'll go right to it. So in your notes, where you're writing this down, you need to put over in the margin page 206, in case you need to go back and look at it. This is highly suggestive, but you need to take an index card or a piece of cardboard or whatever, print this page out, cut that out, and put it on a piece of cardboard or index card. So you'll always have it, especially before this first test, if you're learning it. Okay, what about 6? The number is divisible by 2 or 3, then the number is divisible by 6. And how do you know if the number is divisible by 8? The last 3 numbers are divisible by 8. And just like with 3, if you add the 3 numbers up, 7 plus 3 is what? 10. 10 plus 8 is 18. Is 18 divisible by 9? Yes. Then the whole number is divisible by 9. And then the easiest one, besides the 2 and the 5, is 10. If the number ends in 0, it's divisible by 10. Now, you don't really need to worry about 4, 6, 8, 9, and 10. Why? Because those are not prime numbers. You need to focus on 2, 3, 5, and 11, and 13. That's what you need to focus on. But I always show this whole thing so that way this is something you might want to put in your notebook. Make sure you highlight it, put it on an index card, because it's something you don't want to forget. 2, 3, 5, and that's it. Oh, the numbers on top of the page here. 2, 3, 5, 7, 11, and 13. That's the only ones you need to worry about. So, I know by that chart that my number ends in 4 So that means it's divisible by 2 because it's even. So let's divide 2 into 144. Now, if you will listen to me and you will do what I tell you and not reach for a security blanket named a calculator, you can do this. But you're going to have to knock some of the rust off of the multiplication tables and division tables. And if you haven't learned them, you need to learn them. 2 will go into 14 how many times? 7 times. 2 will go into 4 2 times. Can 2 go into 72? Yes, because it ends in 2. 2 will go into 7 3 times. Look in your head. 7 minus 6 is 1. That leaves 12. 2 will go into 12 6 times. Will 2 go into 36? Yes, because 6 is even. 2 will go into 36 1 time. That'll leave a 1. 16, 8. 2 will go into 18 how many times? Now 2 will not go into 9, so we're going to switch to what? 3. And 3 will go into 3 1 time. When you get to a 1 or lowest prime number that nothing will go into, you're done. So you take your handy dandy blue marker, and this is your prime factorization of 144. 2 to the 4th power times 3 to the 2nd power. And that's how you do prime factorization. Now we're going to spend all day today on that, because you can't suck at that and do the least common multiple and the greatest common divisor, which leads into the common denominator of adding and subtracting fractions. Let's do a nerd. Let's draw my tree, or my 2, 3, 5, 7, 11, and sometimes 13. 1, 6, 9. Now be careful here, because you need to think about it. Think about your multiplication tables and your 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Will any of those give you 169? Well, what's 12 times 12? 144. What's 13 times 13? 169, Hubert. That's right, class. So I can divide this by 13. 13 will go into 169 13 times. 13 will go into 1 time. So this 13 squared is equal to 169. Let's go with 242. 2, 3, 5, 7, 11, and sometimes 13. All right, do that one. So you know it's divisible by 2, so 2 will go into 2 1 time, 2 will go into 4 2 times, 2 will go into 2 1 time. So I'll go ahead and do the 2 for you. 2 will go into 2 1 time. 2 will go into 4 2 times. 2 will go into 2 1 time. Now you need to do something else. See if 3 will go into it. How do you notice 3? Well, it's not 2 because it ends in 1. So try 3 or 4. I meant 5. So 5 won't go into it because it ends in 1. 7 will go in there one time. That'll leave 51. That ain't gonna work. 11. What's 11 times 11? Somebody tell me what 11 times 11 is. It's 121. So divide 11. So 2 times 11 times 11, or 2 times 11 squared.
So I have a question, maybe this is dumb, but so when the first number you get, you do it by each number instead of the whole number, right? Like how you said.
Yeah, if it's 3 or 4 digits, you just want to do each number because you want to keep it simple. You don't want to sit there and go, let's say 13 will go into 169, or you want to do it in parts. Mm-hmm. You'll see after we do 500 or 600 of them. You'll see.
I think that's what I was saying.
Yeah, we'll do another. Let's go to the clear, and let's go to the PowerPoint. Just give me a second. PowerPoint, and I'm trying to get there. They probably have. All right, let's do 1500, but we're not doing it this way. Okay. So let's go back here and let's do 1500. So I'm going to add a new, now remember, put 2, 3, 5, 7, 11. No more sneezing in class. No more coughing or yawning. You only can breathe in here. So 1500. $1,500. 2, 3, 5, 7, 11, and 13. Now it does not matter which one you divide by first. If you want to divide by 3 to make it easier, because 3 will go into 15, how many times? 5 times, right? So that's 3 times 500. If you want to knock it down and get it down to something more manageable, do that. If you want to use 2 times 750, you can use that. It doesn't matter. You're going to get the same answer. How many times will 5 go into 15? 3 times. So that would be 300. You could divide 5 into 1500. So it's not like there is only one way to do 1500. I'm going to use 5. Because 5 will go into 1500. How many times? 300. Now I can use what to go into 300?
Can you go to 3? Okay.
3 or 5. Doesn't matter. I'm going to use 3 because everybody knows that 3 will go into 300. How many times? 100. Now I can use what? 5 or 2. I could use 2. 2 go in there 50 times. Now I can use 2 again, or 5. I could use 5. 5 10 times. Now what will go into 10? 5. And that will be 2 times. And what will go into 2? 2. So here is your prime factorization. Now, some of you did not follow that same methodology, but you're going to get the same answer, because watch. How many 2's do I have? 2, so that's 2 to the second power. How many 3's do I have? Times 3 times 5 to the third power. And no matter how you did it, you got the same one. You got the same answer.
It's in a different order?
Different order.
Okay.
And multiplication is commutative, so you don't have to worry about what order it's in. Now, why do I put the 2 first? Because we all read which way? Left to right. Unless you're from the Middle East, Masalama. If you're from the Middle East, then you read right to left. But most of us read from left to right. So I put the 2 first, then I put the 3, and then I put the 5. Okay? So let's do it in order. Let me go back to, and that's your answer, 2 to the second times 3 times 5. Let's see if I got another example. There's 1,500. Okay, we're not going to go in there for you. So let me go back to the book and find one to do in the book, because I want to give you plenty of examples before we get to, there's 1,500 again. They're only going to give you 2 examples. Yep, that's all they're going to give us. So I'm going to move to the questions. Just give me a second. There we go. Prime. Okay, let's do the prime factorization of 140. Prime factorization of 140. I'll write it on the board. Prime factorization of 140. Two, 3, 5, 7, 11, and 13. So I'm going to give y'all a minute to do the whole thing. While y'all are doing that, I'm going to go ahead and take the roll, get there, give y'all a minute or two. Because it's Friday, and I know y'all want to get out of here, so I'm going to go ahead and take the roll first. Because we got to take the roll. These bureaucrats go crazy and start sending y'all emails. And if y'all get an email saying that you've missed my class and all this, and you haven't missed, don't worry about it. It's just that I hadn't turned in the attendance when I'm supposed to, and the person that has a job doing this sends out an email that says you need to see your instructor. I don't fool with that, okay? I just turned in the attendance late. So don't worry about it. If you come to class and you do your work, you're going to be all right. So let me go to the handy dandy oh my Lord. How many people we got up there easily? 1, 2, 3, 4, 5. So let's see how many's on the roll. Which one is easily, 19 or 5? Oh well, I'll just do this one first. Today is Friday. That's y'all. So there's 4. Who's not here today in Anderson?
Cowan.
Cowan's not here? Okay, now we'll pull up easily. And easily has 1, 2, 3, 4, 5, so that means they are all there. There we go. So that's done, and y'all can, skedaddle as soon as we get finished, unless you got questions today. Okay, so 140, 2, 3, 5, 7, 11, and sometimes 13. Which one you think I'm going to use?
7.
I'm going to use 2. Why? Because 2, the 3 easiest numbers to divide into numbers is 2, 5, and what? 10. All right? I can't use 10, so I got to use 2 and 5. So I'm going to use 2 because it's easy. 2 will go into 14 7 times, and then you just bring down the 0. Can I use 2 again? Yes. You can use 2 or 5, but I'm going to use 2 because it's easy for you.
I used 7. Is that good?
Yes, you can use 7. That's good. You can use 7 also. You can use 7 here. I'm going to use, okay, let's use 7. I would use 2 because I can divide 2 into just about any number that's divisible by, 4 or 7 or whatever. I can do 2 quick in my head. All right, 7, and that'll give us a 10. And then 2, that'll give us a 5. And then 5 will give us a 1. So our prime factorization of 140 is 2 to the second power times 5 times 7.
I got one right.
See? It's not unheard of to do math. Listen, I'll tell you all a little story. When I was at Southwood, I started my 8th grade year, and I was all A student up until the 8th grade. And I had to witch from hell for algebra. Okay? And I'm not going to mention her name, but people in Anderson know this person. Okay? And they all say that she's a terrible teacher. Well, my sister had her, and my sister was the white sheep. I'm the black sheep. My sister made all A's her entire student career up until she graduated Clemson. Okay? My sister made the only C she ever made in all of her years in that woman's class. Of course, I failed. I made a D. Okay? But the whole point was, she was the reason, after the 8th grade, my math grades plummeted. My math grades, I never was able to get back above a C. And she was the reason. Well, she was also the reason I became a teacher, because I knew there was another way to teach, a better way to teach than the way she taught. And I know some of you have run into that same thing, because there's a lot of people that are teaching that should be digging ditches. There's a lot of people that are teaching that should be doing something else. Okay? And sometimes the only reason people go into teaching is because it's not as difficult as other majors. And I hate to say that, but that's the truth. You got a lot of people. I got a good friend and a distant relative that is in teaching, and she should not be teaching because she hates her job. Every day she gets on social media and talks about how she wished she would, the next holiday. When's the next holiday? When's the next holiday?
Labor Day.
I know. But what I'm saying is, she gets on there and she says, oh, when I'll be glad to get off. I'll be glad when the weekend gets here. I'll be glad. If you hate your job so much, do something else. I'm sorry. But anyway, I know how it feels. And it is possible for a student that graduated Westside, 356 out of 360, to get a math degree. It's very possible. So if you feel like you've accomplished something, that's good. Because I'm going to be honest with you, a lot of people don't know how to do this. All right, so I'm going to get off my soapbox. And let's do a nerd. Let's do one that'll make you quit school. How about $3.99? Let's do that one. See if I can get y'all to quit. $3.99. Yeah, we can't do that one. Why? It's too big. So let's just not even do it. Let's just quit. $3.99. It ain't got no zeros or 5s in it. We can't do that one. 2, 3, 5, 7, 11, and sometimes 13. What number do you think I'm going to start with?
3.
3. Good job. I'm going to start with 3. And that's going to be one of those, like you said, you got to do with each number. So I'm going to do 3 will go into 3 how many times? 3 will go in there.
3.
And 3 will go in there.
3.
Now we got a number we don't know we can divide into.
13.
13 maybe? 13 will go into 13, but it won't go into 3. 11. 11 will go into 13 and that'll leave 2, but 11 won't go into 23. 7. 7 will go into 13 and that'll leave what? 6. 63. 7 will go into 63. So let's try 7. How many times will 7 go into 13? One time. 1 times 7 is 7. That leaves 8, 9, 10, 11, 12, 13. That leaves 6. 7 will go into 63. How many times? 9. 7 times 9 is 63, isn't it? Now, what do we have? What do we have there? What is 19?
A prime number.
Exactly, so you're done. Remember me telling you, either 1 or a prime number. That's it. So, your prime factorization of 399 is 3 times 7 times 19. Now, if you want to know the list of prime numbers, all you got to do, and this is one thing that y'all have that I didn't have when I was coming through Tri-County, you have Google. Do you know how many times I use Google a day? Probably 25, 30 times a day. Why? Because I watch TV shows that have big words, and I have people that I'm around all the time that use BA words. I got to look them up because I don't know what they mean. So I go to Google. Go to Google, and let's look up if the dadgum internet's working. Damn Russians. Type in list of prime numbers. There you go. There's the list right there.
Hey,
You spelled that.
Okay, whatever. Smart ass. Okay, there you go. There's all those in magenta. Or if you don't like magenta, my favorite color is yellow. I'm sorry, yellow. There's my favorite color. 2, 3, 5, 7. And see, there's number 19 right there. So you might want to print that out, put it on a card, put it in front of your notebook so you can remember the prime numbers. Because I can tell you right now, 80%, or not 80, 40 to 45% of your Unit 1 test is going to come from 5.1. Okay? So you're going to have several of these questions on your test. There's a small one right there. If you like Verde, Dango Amarillo, Dango Verde. How you say, ¿Cómo se dice magenta español? I have no idea. You have to look that one up too. Huh? Magenta. How do you say magenta in Espanol? Let's look that up. So you can look up anything. Spanish for magenta. This is the kind of stuff I do when I'm watching TV or when I run into something I don't know.
It's just magenta.
Now, okay, it's just magenta. All right. My grandmother, she used to write things down on pieces of paper and look them up later. You ever met somebody that's done that before?
Mm-hmm.
Well, that's what I do. I just do it with Google. And I just learn all kind of stuff. That's how I learned Amarillo is yellow in Spanish. Learn all kind of stuff like that. So it's just magenta, and I guess it is Spanish for magenta.
Go to all and see if it'll speak.
Magenta.
Yeah, magenta. Magenta. Okay, you have to sound Spanish with it. Magenta. All right, let's do some more. Let's do some more because we need to give y'all plenty of examples so y'all don't use that excuse when you go home. Oh, I didn't know how to do it. Trying to find my book. Hold on, where's my book? My book disappeared. Where'd my book go? Oh, there it is. I gotta find it. There it is. Okay, let's try 1336. 1336. And if you can do that one, you can pretty much do prime factorization. And then I got to add something to it so you can quit. 13, 36, 2, 3, 5, 7, 11, and sometimes 13. Now it ends in 6, so you know it's divisible by 2. If you want to start out with 2 to whittle it down to a smaller number. That's what I'm going to do. I got to check my phone. I'm trying to get my Math 110s online to Skype in today.
Hey there, you just.
Now
there it is.
you can hear us now.
We've been muted for like half this class.
Quiet.
Why did y'all mute it?
We didn't realize it. I noticed everything was red, so I'm like, I don't think he can hear us.
But you asked us, somebody asked a question earlier and you could hear them, so I don't know.
Yeah,
Right.
it's the Russians.
Y'all are failures in life.
I already
Y'all
knew
will
I
not
was.
have a chance in Hades to pass this class. So y'all might as well quit.
No, don't underestimate me. I can pull through.
I ain't gonna prove it.
I have
I'm blind.
the terrifying ability to pull through at the last second.
Can we ask the question, please?
No, I'm off the clock right now. Yes, ma'am.
Is there some type of website or something we can go that can actually teach us this so that when we do get home, we can practice it? Because I'm getting some of it, but then when I think I got it, it's not registered.
Yes, YouTube. You watch this video over.
You talking about the one that you're on?
Yes, I'm recording this. Yes,
Okay.
and that's the whole purpose of me recording this. Because what happens is either students miss the class or I go a little bit too fast, and that way students can stop the video and watch what I'm doing. So what happens in class, sometimes you're writing down and you're not concentrating on what I'm saying. So the video gives you a chance to watch it and not have to write everything down. Or vice versa. You can write more down and stop the video. So I would suggest just go to my video and watch it.
Okay.
That's
Thank you.
what I would suggest.
Call it YouTube.
Yep, YouTube.
You can always use Khan Academy.
There's a lot of
So,
things on.
I'm going to divide 2 into 13. 2 will go into 13 6 times. What's 6 times 2? So that leaves a 1 right here. So 1 and 3, that's 13. So 2 will go into 13 6 times. That'll leave a 1. 2 will go into 16 8. Now, if you don't understand what I just did, go over to the side and say 2 will go into 1336. I would rather you do this than use the idiot box because the idiot box we don't need right now.
Okay, so I'm not the only one that sits there and does
Okay.
that.
Don't use the calculator because that's a security blanket. No offense, but you should not be a graduate of high school and not be able to divide 2 into 1336. You should be able to do that. So 2 will go into 13. 6 times. 6 times 2 is 12. There's that 1 I'm talking about. Bring the 3 down. You see what I'm doing? I'm just doing it in my head right here. I'm doing it in my head right here, but if you need to go over to the side, do it over to the side. 2 will go into 13 6 times. And then 2 will go into 16 8 times. Okay, now, 668, is that even or odd?
Even.
It's even. So now you can divide 2 into 668. Oh, no, don't give up. I kid around and tell y'all to give up, but I don't want you to give up. Okay, how many times will 2 go into 6?
3.
How many times will 2 go into 6?
3.
And how many times will 2? 4. We still have an even number. So 2 will go into this. So do that. 2 will go into 3. That'll leave a 1.
That leaves
13. How many times will 2 go into 13?
6.
6. That'll leave a 1. How many times will 2 go into 14?
7.
There you go.
Look, now it's not an even number.
It's a miracle. But you did it.
Oh, wait.
I was so confused because for some reason I was trying to get 2 out of 3.
Yeah, sometimes you try to get the numbers to work and they don't.
You put 2,
2 will go into 1. 2 will go into 3 one time. That'll leave a 1, right?
Mm-hmm.
How many times will 2 go into 13? 6. And how many times will 2 go into 14? Now, let's just go through and look at the numbers. We know 2 won't go into 167. We know 5 won't go into 167. So let's try 3. 3 will go into 16 5 times. That'll leave us 17. 3 won't go into 17. 7 will go into 16 twice. That'll leave 27. But 7 won't go into 27. 11 will go into 16 one time. That'll leave 57. That won't work. 13, that won't work. So we may have another prime number. So let's go back to our Google. And I don't mind you using Google for this because there's no other way to tell if 167 is a prime number unless you either type it in or you count. And I don't want you to have to count because that just takes too long. Okay, so I'm going to go over here and I'm going to type in prime number.
Yes.
Prime numbers up to 200. You can do that if you want to. And you might get it, look there, 167. Or 157, which one was it? 167 is prime, so you're done. So see, you stopped at 167, not because you were confused, because 167 is a prime number. So the answer to this one is 2 to the third times 167. And the reason I'm going over so many problems is because of what you just said, need to watch the video. That's why I'm going over so many of these problems, because I want you to go over and over. Let's do one more. What time is it?
We got 1 minute.
I got 1 minute. We're going to do one right quick. And this is what I suggest you do. You go to the homework. We'll just go to the homework. Let me go to the homework right quick. Let me find, here we go. Go to your, where is it? I'm looking for assignments. There it is. Assignments, 5.1. I'm waiting. Okay, well, when you go to assign, there we go, 5.1, ignore 1 point, we're going to 5.1. I haven't turned them on. I need to turn them on. I suck. Hold on. Okay, let me do this. It's easier to go through here and do this. Okay, 5.1. Let me go ahead and unassign those two. And hit 5.1, 5.2, 5.3, 5.6. Don't y'all do 10.1 also?
Yeah.
Somebody look on your outline.
Yes, we do.
Okay, and I'll go up here and I'll hit, today is, what's today?
23rd.
Today's the 23rd?
Yes.
Okay, and 8 o'clock this morning. And I will leave it open. There we go, update. Okay, I know some of y'all are going to go into convulsions. Just hold on. I know you're going to turn into a pumpkin. But
We'll pray for
main
him.
menu. Okay, when you go to assignments, and this is to answer your question, you go to 5.1. What if you have a question on it? What do? You send it to me. You send it to me, and hold on. That's not what I want. Please hurry up. They got a lot of, okay. Let's say you do this one at home and you can't do it. What do? You try to go through these, but if you can't do it, you send it to me what? Ask my instructor. And what am I going to do Monday when before class starts, what am I going to do? I'm going to go over those questions. So between the video and between these help me solve this right here, and then if you can't do that, you send it to me Monday morning, I'm going to go over it for you. Capiche?
Gosh.
All right, y'all get out of here, have a good day, and I will see y'all Monday.